Welcome to the lecture number 11 about annual equivalence analysis. This is another important subject because it can allow us to calculate the annual cost of any machine or any asset we buy today, and any asset that can have in the future operation and maintenance cost, and then you can calculate the annual cost, equivalent annual cost of using this machine or this network, and compare among several alternatives you can have. So this is a very useful, and then also this annual equivalence analysis is very used by the regulatory agencies in the world when they calculate the price or the cost of electricity or of minutes of mobile services and so on. So this is a very useful lecture in that sense. As usual, the recommended textbook for this course is the Chan Park Fundamentals of Engineering Economics from Pearson Education. The annual equivalence criterion. This is the concept we are going to learn and to use. The annual equivalence criterion. What does it mean? Annual, we are going to estimate an annual calculation. Equivalent, in that sense, is annual equivalence. And also, it's a criteria, so we can use that calculation as a criterion for selecting among alternatives. So, as you see here, the annual equivalence is the second major equivalent analysis after net present value for translating different alternatives into a common basis for comparison. So, first used technique for comparing project is net present value, and then the second most used is the annual equivalent. So as I have explained it in the presentation, with this technique, with the annual equivalent criterion, we are converting all the investments and future cash flows to an equal annual payment, like the PMT factor we are estimating several times. So we are moving all the future cash flows and the capex or the initial payments. We are calculating a representation of this of those cash flows just in one number, which is the equal annual payment. So first step, we calculate the project net present value, we know that, and then we convert this net present value into an equal payment series at interest rate, the cost of capital during the project duration. And then once we have calculated the annual equivalent of a project, we can apply in different situations. That the first one I have said is the equivalent uniform annual cost, the EUAC, to know the annual ownership cost of a new asset. This is a very, very big tool for companies because they invest in assets, facilities, and so on. They have operation and maintenance cost every year for keeping those assets or machines or facilities in well use. And then they want to know what is the total cost ownership of this facility, of this service. So this is a very big issue for companies. They always try to know the TCO, which is perhaps you have heard before, the TCO. What is we are going to learn. Another concept is use of the annual equivalent criterion is the equivalent uniform annual value. So the difference between this is cost and this is value. So There are investments that can generate savings for company, and then with the equivalent uniform annual value, we can know, we are able to know the annual savings may generate a new asset. Imagine that you want to estimate, to decide if buying or updating a machine or buying a new one that will generate savings in the future. This investment today deserve for the project savings you are having in the future. So for that reason, you have to calculate the annual savings, equivalent annual savings you are getting from the project. For example, we can compare the annual cost of purchasing different alternatives in order to select the cheapest one. So as you understand, this is a very big issue for companies. They are quite interested in applying what you are learning today. Let me explain with this diagram the general idea. This is our conventional project, this one. We have here the project cash flows. I'm going to introduce a new concept, which is the salvage value. Let me do later. And then we have any kind of project cash flow. We have here the CapEx. So we bought a new machine this year, a new asset purchase. And then this project in time zero. And then in the following times, the different periods of time, we are having project cash flows of year 1, year 2, year 3, and so on. And this is the end of the project. The project life is 6 years in this example. And then what is the salvage value? The salvage value is that any asset we buy, at the end of certain time, in future time, it has a market value of buying, of selling this asset. For example, let's see a quite domestic case. We buy today a new car. We pay for that car 18,000 euros. And then 5 years from now, we decide to change our car and buying a new one. What is the salvage value of our car? We bought by 18,000 euros. What is the price 5 years? In 5 years, what will be the price, the market price you can buy, you can sell this asset? Imagine that 5 years from now, you go to a car dealer, and then you want to buy a new car, and then you ask to the car dealer, how much will you pay for my old car, my used car? And he said, the market value of your car, the salvage value of your car is, for example, 4,000 euros. So that value in the future that you can sell this asset is the salvage value. Certain times the salvage value is equal to 0. When? For example, when the asset is technology based and the technology has a lot of obsolescences, and then anybody will want you buying your old computer, so the salvage value is 0 because there is no market for so old and antiquated computer. But many others, there are second-hand markets that many companies or individuals are interested in buying your old asset. So that's the salvage value. Why is important for us the salvage value? Why do you think? Because in our project cash flows, we have to consider all the cash flows, all the expected cash flows. So as one cash flow is buying the asset, the purchasing of the asset, and we use the minus sign to represent it. We are also considering future cash flows of the project. Why not? We are obligated to that, to consider future cash flow, in that case is the salvage value is a positive one, is an inlay, because we are selling this asset. So considering this as also as part of the cash flows, it will increase the last year cash flows with this amount, with the salvage value. So in that sense, it's clear. And then let me then to continue in order to know the annual equivalent criterion. So first step, to have the project cash flows, to know the capex, and to know the salvage value. Then we know that to calculate the net present value of the project. We know that the net present value of the project at interest rate, year and years, and then considering all the cash flows of the project with their respective sign, the capex and the salvage value as well. And then we calculate the net present value of the project. So let's see the second scenario for calculating the annual equivalent criteria. So we create a new artificial one, cash flow, which is this one. We are investing today this amount, the net present value of those previous cash flows. And then we know that we consider that this is our investment, the net present value, and we want to know what is the equivalent annual payment, uniform annual payment, that we can get from investing that net present value at the cost of capital of I during the project life. Sorry, this is a misprint. This number must be 6. So we know that investment plan is that to invest today and money and get some money in the future from that investment. This is annual uniform equal payments. And then we know that formula. This is the formula of equivalent uniform annual cost is equal to the payment, annual payment of interest rate and years. And in that case, the present value is the minus net present value, and the future value is 0. So, as you see here, this amount is constant, is uniform over the year. So, we are representing different cash flows, numbers. For example, imagine this cash flow is 100, this one is 200, this cash flow is 300, and then this cash flow is 150, and this cash flow is 400, and this cash flow is 420. And then we are representing the same cash flows just by one amount, equal amount, annual equal amount. So that's the most usefulness of this methodology, that we have to compare several projects with different profiles of cash flows, with different one. For example, in year 1 are higher, and the second year higher, and then in third year they are lower, and then in year. So we can compare several projects with different profiles of cash flows, compare into an annual equivalent measure. And then a project qualifies according to the next rule, which is quite so obvious, as we are seeing here. If the annual equivalent payment is higher than 0, we will accept the project. And then if the annual equivalent is lower than 0, we will reject the project. This is obvious. Why? Because as you see here, the annual equivalent has the same sign than the net present value. So as the net present value has the same rules, then the annual equivalence has equally the same, exactly the same rules. Let's see an example. I'm sorry you don't see due to this tool in the screen. So you see here the title, the head of the slide is resolving a present cost to an annual cost. This is the concept of capital cost of an asset. Okay, so what are going to know in this slide. We buy today an asset of 1,000. This is the capex. And then you have another option to do with your 1,000 euros. For example, going to a bank, deposit, and investing it at 3%. So in all the cost, the capital cost of an asset is you have to consider not only the nominal amount of the capex, 1,000, but also you have to consider the cost of capital of investing in this project instead of going with this money to the bank to a deposit for asking to ask for a deposit. And then, as we have to include the cost of capital in our calculation, we want to know, as manager of a project or as a manager of a new facility, to know the annual cost of this asset. And then, with this methodology, we are going to convert a present sum to a series of equivalent uniform end-of-period cash flow. This is the capital cost of owning an asset. As I have said in the first slide in the presentation, this capital cost of owning an asset this is a methodology quite and very often used by regulatory agencies when they regulate prices. For example, imagine that you construct a new mobile network. So this is a new mobile network. You are a telecom company investing in towers and radio equipment and so on. And then the regulator, one of their tasks of its task is to calculate the cost of 1 minute of mobile telephony. And then part of this cost, as you understand, those are assets. The mobile network has a lot of assets like tower, radio frequency equipment, optical fibers, and so on. So part of this cost of 1 minute of mobile service, part of this cost will be composed of the cost of assets. And of course, as for example, Vodafone is investing in this mobile network, also the regulator considers in its calculation not only the cost of the asset, but also the cost of capital of Vodafone. So, because Vodafone has another option to invest their money, its money. They can invest 1,000, invest in another projects or another financial product. So, as you have to calculate the cost of using the mobile phone, you have to consider the cost of capital of Vodafone. And then let's see an example. A company bought a new machinery for assembling electronic components for producing circuit boards. So we are talking about a new machine. The machine cost 3 million euros. Its useful life 5 years, 3 million, 5 years, and the salvage value is 0. So you can't sell this machine 5 years from now because it's obsolete. And then you, as the facility manager, you want to calculate how much cost the use of this machine in every printed circuit board you are doing. So you have to consider the cost, the capitalized cost of the machine. Okay, so with that, with this tool, we are able to calculate. So the question we have to ask is, what is the equivalent annual capital cost of owning the machinery? So what is the cost of capital for this company? Is 12%. So the alternative rate of return, the minimum they are asking is 12% because they have another projects to invest, and they ask for 12% in the projects. So let's see the cash flow diagram. Is we want to convert the payment, the capex payment of 3 million today into an annual equivalent payment. So as you see here, the present value, net present value of the capex is the same net present value, the same capex. And then we are estimating the annual cost, the equivalent annual cost of this, using this machine. The useful life 5 years, the cost of capital 12, the present value is the acquisition cost of the machine, 3,000 thousands. The future value of the investment, this one is salvage value, is equal to 0 in that case. So the formula for annual equivalent cost is the payment, annual payment of n years, interest rate, present value, the acquisition cost, and future value, the salvage value. So this is the formula used in Excel or in the financial calculator. The payment, will be the annual equivalent cost, is equal to the payment of during 5 years at 12% of cost of capital, of an amount, initial amount, present value of 3 millions, and of a future value of the machine of 0. And then the annual equivalent cost of using this machine is 832,000 euros. So this is the annual capital cost of this machine. So let me explain what is the useful of that. So you have bought a machine for 3 million euros. Then you are producing, for example, 10 millions printed circuit boards. This is the output per year. And then you want to calculate what is the cost that you can allocate to every printed circuit board, the cost of using this machine. So, as we have calculated, the equivalent annual uniform cost of this machine is 832,000 euros. The annual production of this machine is 10 millions PCBs per year. So the cost of the machine per every printed circuit board is equal to the annual equivalent cost divided by the production, equal to 832 divided by 10 millions. So I think it's not much. Perhaps the production will be best reflected using just 1 million. And then let me calculate. This is 0.832 divided by 10. So every circuit board, it's quite cheap, has a cost for using the machine equals to 8.32 €. So, okay, so I haven't exaggerated the production, but for example, if the production will be 100,000, then this cost will be for every printed circuit board, the cost of the capitalized cost of using the machine will be 832 divided by 100, and then it will be 8.32 euros, which is more realistic assumption. So you see here the very usefulness of this methodology. Have you got any question? I think it's clear. And very useful that. Next slide. Now we do the same example with salvage value, just to complicate the things. The salvage value is 800,000 euros, so we buy 3 millions, and then we can sell 5 years from now by 800. The calculations are the same, but you see here the payment of 5 years, 12%, present value, this is the capex, 3 millions, and the future value of the machine with different sign, minus, in order to be coherent. This is indeed formula you can use, you can exchange the signs, but being coherent using different sign in the present and the future, the salvage and the capex. So the annual cost is 706 and 6 euros. Why is lower? It's quite straightforward, because in the case of no salvage value, as you don't have future earnings, future incomes or insource from the selling of the machine, the cost is higher than in the case of this one. This case is 100 euros less, 1,000 euros less, because you have here future earnings of because due to the selling of the machine. So this is straightforward. You see here the formulas with Excel. And then let's see the total cost ownership of buying a new asset. So imagine that you are an entrepreneur and you construct, you develop, and you buy one IT system that has a cost, the capex, is for example 500,000 euros. This is the capex. And then also you know that in general in the IT world, the operation and maintenance cost of any IT system is something like 10-20% of the initial investment. So this is a common metric used. Let's imagine this is the 10%. So annually you have to invest. You have to expend in operating and maintaining this machine the 10% of the capex. So you have a operation and maintenance cost in the future of 10% of 500,000 is 50,000. Okay? And then you want to know what is the total cost ownership of this IT system you have constructed. So you have an initial amount investment, you have different future operation and maintenance costs, and then the entrepreneur wants to know what is the equivalent annual cost of having bought and constructed this IT system, and also the having into account the operation and maintenance cost. And then he want to say the total cost ownership of this IT system is, for example, 80,000 euros per year. Because you want to compare your total cost ownership with your competitors, with another offer you have from another provider of IT system, and the other provider says, for example, that the total cost ownership of their proposal is 70,000 euros. Which system will you choose? The total cost ownership of project 1, of system 1, is 80,000. The total cost ownership of system 2 is 70,000. It's obvious that you will choose the system 2 because its total cost ownership is lower. So it's very, very useful, this tool. And then this is the concept of total cost ownership, to take into account the capex and the operation and maintenance cost every year you have. Of course, during the useful life. And then the methodology we use is to calculate the present value of the future annual operation and maintenance cost, the so-called net present value of operation and maintenance cost, at the capital cost of capital. Then you add up the capex and the net present value, because both the future operation and maintenance cost and the current payment you are making in capex, both of them are outlays of the project. So that's the reason you add up them. And then this is the concept of the asset present value. Also, if we have salvage value for the system in the future, you have to take into account. And then what we do is that as we have the asset present value equivalent to the net present value, is a concept similar. Using the annual equivalent criteria, we have learned this. The concept is similar. Will be the payment of n year, the interest rate I, the present value, in that case the adjusted present value, and if we have salvage value minus salvage value, because the capex and the operation and maintenance costs we are considering as positive, even being the outlays. In the case of salvage value is as being an inlay, but we are using the inverse sign for inlays, so minus. And then this formula will be the annual equivalent cost for this system. So please remember this formula, because sometimes in your future professional life you will be using, or you will be asked to use, or you will have a chance to demonstrate your professional qualification, because you will be able to calculate that. The total cost ownership of a system is equal to the component, has two components, due to the capex, due to the purchase of the machine, and another portion is due to the operation and maintenance cost. So as you see here, the total cost ownership has two different components in relation with the capex and in relation with the operation and maintenance cost. And then the capex related portion is what we call the capital recovery cost, and the other portion of the relation related with the operation and maintenance cost are the equivalent annual operating cost. And then the total cost ownership will be the summation of both components. The first one we know to calculate, we have done before, is the capital recovery cost of a machine, which is the n years equal interest rate, the capex, and the salvage value with different sign than the capex. And also we know the equivalent annual operation cost of a machine, we have learned before, which is the annual equivalent cost. And then this is the payment of year end, interest rate, and the net present value of annual operation and maintenance cost, and then future salvage value, of course, is 0. So let's apply this formula. This is we are going to calculate the annual capital cost of an asset with operation and maintenance costs. This is the most difficult case. So we have an asset with a capex. It will generate future operation and maintenance cost. Also, it will have a future salvage value. We can sell this asset. And then we want to know the cost, the annual cost, the equivalent annual cost of using this asset. For example, what useful case for engineers? We work in an electricity utility company, and our company asked to us that to calculate certain investment numbers, because they are planning to build a new 300 megawatts power station with the same technology of another it has. So we are constructing a new, for example, thermic power station that will be generating electricity. Okay, so we are going to invest a lot of money. The project life, as you imagine, will be very large, and every year we are having operation and maintenance cost, because this power station must be kept in running rightly. How much does the power station cost? The capex, 300 million euros. I have tried to use the most real numbers, so perhaps you can consider this as a real number. A power station of 300 megawatts power station has a cost about, more or less, depends on the technology, from 1 million euros per megawatt to 2, 3, depends on the technology. And then 300 megawatts by times 1 million per megawatt is 300 million. The useful life is 20 years, and the salvage value is 20 million. So part of the machine of the power station can be sold in the future, but for 20 million. The annual operation is 4,400 hours. So during a year, there are a total of 365 times 24 hours, like 80,000 hours per year. So we are using that amount, 400. Let me explain that. 365 times 24 hours is equal to the number of a year, hours of a year, which are 8,070 60, this is hours, okay? So divided 1 plus, divided by inverse, times 4,400. This is the performance of the production regime of the machine is 50%. So just take it into account. So the machine is producing 50% of the time. The engineers, as the technology, they are experienced with that technology, they have got the annual cost of operation of maintenance of equivalent power station. And then we want to know what is the equivalent annual cost of the power plant if the cost of capital is 12%. 12% is a conventional cost of capital used for energy companies. We see here the business plan. Here we have equivalent annual cost, then number of year 20, the cost of capital 12. We have here the table with the engineers has provided to us the operation and maintenance cost in every years, from year 0 to the year 20. The operation and maintenance costs are those one in millions euros. And then we have to calculate, as we have explained it, the net present value. We have to calculate the net present value of the operation and maintenance cost. And then, as you know, you will be discounting every cash flow to calculate the discounted cash flow, dividing by the interest rate, 12%. And then the cumulative sum of that will be the net present value of the operation and maintenance cost, 460 euros. 60 million euros. This is the present value of operation and maintenance cost, the same amount. And then, as they are cost, we have to add to the current cost of the machine, which is the capex, the acquisition cost. The salvage value is 20 million, and then We have the adjusted present value, is just the sum of the summation of the present value of operational maintenance cost plus the acquisition cost, which is 706 euros, 6 million euros. And then we calculate the formula with the equivalent annual payment, the payment of the interest rate, the number of years, 20, the APV, and then the salvage value with negative sign. So at the end, you see here all the formulation, all the formulas. The annual equivalent cost of this power station is 94 million euros per annual. So this is the total cost ownership per year of owning this and operating this machine. So let's calculate the cost of production per kilowatt hour of energy produced. As you know, to know the energy, we as electricity consumer, we consume energy. This is a time unit. So this is equal to the power times the period of time used. And then if the station produces 4,400 hours per year, we multiply by the power of the station, which is 300, and then the total production of this, the annual total production of this power station is 1,320 gigabytes per hour. And then if we divide the total cost of using this power station divided by the production, the total production, we can have the unitary cost of production. So if we divide the annual cost of 94 million euros divided by the total gigawatt hour per year, we have a capital cost for using this central power station of 7.1 centi-euros per kilowatt hour. Just to compare with, this is a very real number, because you can consult in the web page of any electricity company in Spain, the price of electricity is this one. So let me just to notice that this is a misprint. This price of 13.860, this is either centi-euros or 80 euros per megawatt. So as using, for example, the centi-euros unit, so the price of energy in Spain is 13 centi-euros, 13.9 centi-euros per kilowatt hour. And the cost of generating energy using those numbers is 7.1 centi-euros. So that gives us an idea of the usefulness of using those methodologies. And then you see here the equivalent uniform value. So it's quite straightforward. You can study by yourself. The useful of this methodology is we are estimating the value of future things. So in that case, we want to know, for example, this example, an hospital plans to purchase new equipment for improving the performance of the current boiler of the company, of the hospital. This updating of the machine cost 159,000 euros. With a service life of 12 years, the cost of capital is 10 years, no salvage value. What are the annual savings of this buying this updating of this machine? We have here in that table, we are provided with that table, that adding this new equipment to the boiling machine of the hospital will be generating these future savings. So we want to know if the purchase of this new part of the machine deserve for the future savings we are generating. So this is a quite conventional calculation. The main difference between the case of the annual cost or the annual value is that we calculate the adjusted present value, not adding the net present value of operation and maintenance plus the capex. No, we do different, because the savings are positive amounts and the purchase of the machine is a negative one. So we subtract. So we have we have the minus sign here, and then the adjusted present value is this one, and then we calculate the annual payment of this one, and then what is the annual savings this hospital is having, investing today 159,000 euros, and getting those annual savings that they will generating an equivalent annual savings of 42,507 euros. So this is the annual savings this project will be generating. Okay, so that's the last slide. So as you see, we can use for calculating this methodology for cost as well as for savings of the result of buying a new machine. So have you got any question? So thanks for your time, and I hope that's all clear for you. You have anyway my email, and in the next week I'm publishing the problems you have to do during these 2 months, and I hope everything is okay for you with them. And then anyway you can have questions you can ask to me. So bye, see you. I think in the first week, we have to change the first week of May, because it's in the middle of the so-called bridge, a bank holiday. I think the 3rd is in the middle of 1-2 of May, which is Wednesday and Thursday. So the 3rd is in the middle of one long bank holiday, so we will move them. I will inform you in advance. So thank you very much, students. Bye-bye.